Hello, in this video we will work out an example of rectilinear motion, which we learned how to solve those kinds of problems in the previous video. So the problem is a man is standing on a 112 feet high building. He throws a projectile, let's call it a ball, up with an initial velocity of 96 feet per second. And we are asked a couple of questions regarding the position of the ball. So we know that our initial height is 112 feet. We know that our initial velocity, like stated here, is 96 feet per second, and we know that gravity is 32 feet per second squared based on the previous video. We already know that, that's kind of a given. And so, as you might recall, our position function is negative a half g times t squared plus b naught times t plus h naught. And that is our that's the formula for where the ball is at a given time. So let's answer a couple of questions. So our first question was actually to find the ball's height and velocity at time t. And as you might see here, we already know the height of the ball given any t with this function. So that is actually the question. So finding the ball's height at time t. And now to find the ball's velocity, we want to find the derivative of the height. And so in order to do that, I'm sorry, we were not done with the previous question. Actually, let's plug in the actual value. So h of t is equal to negative a half times 32 times t squared plus 96 t plus 112. So this is our actual answer to what is the height of the ball at any given time. And so our next question, to find the velocity, well, we know that h of t we found out to be negative 16t squared plus 96t plus 112. So h prime of t, that's the velocity at any given time, it's just the derivative of that. So remember, we will work with the sum rule right here and also with the constant multiplier rule and the power rule. So our first term turns out to be negative 32t plus 96. So this is our velocity at any given time. The next question to answer is, when does the ball hit the ground and what is its impact velocity? So the next question is, how long does it take to hit the ground and with what impact velocity? So in this case, we have our function of h of t, and we know that the ground is right here. So our initial height is 112. So the ground is at 0, right? If we had said that our initial height was 0, then the ground would have been negative 112. But in this case, it's a little bit easier. So we just have to find the 0 of our polynomial, negative 16 times t squared plus 96t plus 112. And so this is kind of easy. We already know how to do it, but just as a reminder of our Algebra 2 class, let's work it out. So we can factor out the negative 16, and we're left with t squared plus minus 16 minus 7. And we factor this out, and we find out that this polynomial is equal to 0 when t is equal to 7 or negative 1. So we know that time cannot be negative, and so our answer here is at t equals to 7 seconds. And now we need to find out the velocity given this time. We already know the equation of velocity, and so we just plug it in. And so we have that v of t is equal to negative 32t plus 96. And we want to find b of 7. That's negative 32 times 7 plus 96, which is equal to negative 224 plus 96, negative 128 feet per second. And so we see that it hits the ground pretty hard. And this makes sense, right? So when it's about to hit the ground, its velocity is downwards, since gravity accelerated it downwards. And so having a negative velocity makes sense completely. And 7 seconds, well, that's not much intuition. We just have to take it for granted that it's right. So that's it.